have a first quick question. Has it ever happened to you to feel your phone vibrating in your pocket, take it out, and there was actually nothing on it? Yeah? Raise your hand if it happens. Okay. It's actually more than average, by the way. It turns out that 9 out of 10 people already experience something that's called phantom vibration. It's literally when you think your phone vibrated, but in fact nothing happens. Which is quite amazing, you know? I mean, it's somehow we are just inventing things. Do you know what's the other name for it? Can you guess? A hallucination. It makes everybody laugh, but actually I'm pretty scared about it. Because when you think about it today, with just a smartphone and a computer, we got so conditioned by technology that we're inventing things that don't exist. How many things can you name in your life that makes you hallucinate like that? Right? And so when you project yourself in this future that everybody's talking about, where everything is connected, you know, what's going to happen? What's going to happen when your chair and your table and your TV and everything here is going to be competing for your attention, requiring more and more brain power to actually, you know, live alongside you? Are we actually going to become robots ourselves? We're expecting over 100 billion connected devices in the next 10 years. That, for me, is really scary. But we have actually a solution. It turns out that the reason why it's so hard to use technology today is because ever since we invented technology, we had to learn how to use every one of those machines. Buy a coffee machine, you gotta learn how to use it. Buy a washing machine, you gotta learn how to use it. Buy a computer, you gotta learn how to use it. So the more technology we wanna use, the more effort we have to make to learn technology. And this is the reason why we're feeling saturated today, is because we've had too many things we had to learn. But if you can start talking to those machines the same way you talk with people, then perhaps you wouldn't have to learn how to use them anymore. Because at the end of the day, you know, who cares about how a machine works if you can just ask it what you want? I don't care, you know, to find like the button for the cappuccino on my coffee machine if I can just ask it to make me a cappuccino. So the way we look at it, we believe that AI can make it a lot more intuitive to actually communicate with machines and remove the need for you to learn it. So AI is something that's been growing very, very fast in the past few years. I think everybody here has probably seen some sort of AI cool stuff in the news in the past couple of years. It turns out that those algorithms exist for, you know, decades. The two things that made AI grow so quickly is actually the combination of almost unlimited free computing power and an ever-growing amount of data to teach those machines to do things. So cloud computing is an exponential trend, big data is an exponential trend, and the combination of the two is what's enabling AI today. So the reason why AI is growing so fast is because data and computing power is becoming more and more available. So what that means is that if you consider artificial intelligence as the solution to all those problems we're facing with technology, then there is a future. I'm expecting something in the last 10 years, very scientific chart. There is a future at which point we can expect basically the feeling of technology to completely change, right? If AI is the solution to the overwhelming technology we have around us, then our experience is completely going to change in the future. What I believe today is that if you can talk to every one of the machines around you, you wouldn't have to make any effort anymore. Everybody will be able to use technology, so you're democratizing access, and it'll become so intuitive that you're never going to care or think about it anymore. It'll become like electricity. You know, it's something that's just there that you use that you don't think about. You know, you didn't get in that room thinking, oh my God, there's electricity everywhere. It's going to be the same thing. You're never going to actually feel technology anymore. AI is actually going to make technology disappear. So what is actually AI? Can someone give me a definition? You're looking at me, I think you know. What's AI?
The ability to learn, technology to enable the technology to learn by data to predict the future and feature applications.
Yeah, maybe. I mean, everything you said is true, but it's not just that. So who has heard about AI? All right, good, okay. And yet nobody can define it. That's a big problem, because how are you meant to actually think or use AI if you don't actually know what it is? So for me, AI is very simple. It's the ability to reproduce human behavior in a machine. It's that simple. So anything that a human can do, if you make it in a machine, then we're actually building AI. And there are many, many, many different ways of creating AI. One of them is very popular, and it's called machine learning. The idea here is that instead of telling the machine what to do, you're showing it examples of the behavior you want it to reproduce. And the machine will learn from those examples to reproduce the behavior. Just like a human, you show someone a chair 5 times, they get it, this is a chair. It's the same idea here that you're doing with a computer. This is very important because up until now, the only way that we could make machines do things was to have a human expert figure out the behavior and then program the machine to do it. So a human had to understand what was going on and then write code for the machine to do it. But with machine learning, you don't have to worry about how it works anymore. You just need to collect data, so showing examples of the behavior to the machine, and it will learn to automate it itself. And because it's so much easier to collect data than become an expert in something, you're getting a much, much faster automation of everyday stuff. So machine learning is really a change in the way that we make machines do things. And within machine learning, there's something called deep learning, which is a specific method of machine learning to learn those things. So deep learning is a branch of machine learning, which is a branch of artificial intelligence. And today, all three are used interchangeably when people talk about AI, but they're very distinct things. And in the future, we're going to have more technologies in deep learning or machine learning to do AI. So how does deep learning work? It's not that complicated, to be honest. It's actually deceptively simple in terms of mathematics. The idea here is that you want to have those sort of layers of neurons. So each of those dots here is an artificial neuron. And they're connected to the neurons below them. So the ones on the first thing here are connected to all the ones on the next one, which are connected to all the ones on the next one, and so on and so forth. These neurons are just numbers. And the way that you're learning things is that you're changing how connected those different things are between themselves. So let's say you want to learn to recognize cats in a picture. What you're going to do here is instead of telling the computer a cat has pointy ears and a fur and everything, you're just going to show the computer hundreds of images of cats. Each of the pixels of the image is going to be one of the neurons in the first layer. So the computer here only has the pixels of the image as the input. You've never told it anything about what a cat is. By combining those pixels over all those images, eventually it will learn, there is something I see on a regular basis which looks like an edge. So the computer learned from those pixels the concept of an edge. And now that it knows the concept of the edge, it can combine those edges to learn the concept of a cat's face. And now that you have this, you can recognize a cat. So this is basically how deep learning works, right? You're iteratively rebuilding concepts that you're reusing to create more and more abstract representations of things. And all of machine learning is using this today. Self-driving cars, very big use case, everybody's talking about that, massively disruptive, big success of AI today, using this type of stuff. Radiology, big thing. Anything related to images, by the way, we can do better than humans now with machines. Radiology, recognizing diseases in MRI and radios and things like that. Same algorithms. This is something called style transfer. I find that actually quite interesting. The idea is that the machine here is learning to reproduce the behavior of an artist by looking at all the paintings of the artist. So here it's learning the style of Van Gogh, then you give it a picture, and just like an Instagram filter, it applies the style of Van Gogh on the actual picture. This is old technology. This is like 2014, I think, right? Which in AI is old technology, by the way, because what happens in the last 3 years is exponentially more than what we had before. So think about it this way. If a computer can just look at a few examples of an artist and reproduce his style, what does that mean for art production? Does the artist just have to give like the first piece and let the computer generate hundreds of thousands? There's a lot of things that this changes actually in this concept. This I'm particularly excited about. We can now have AIs generate images just from a drawing. So in this case here, you just draw a handbag on a piece of paper, give it to the machine, and the machine will generate a high-definition, three-dimensional rendering of the bag that you can then change the color, change a few things. What does that mean for industrial design, architecture, product design, fashion? If you no longer have to learn how to use those very complicated CAD tools, and you can just sketch something on a piece of paper and get a computer to produce it. And this is very important because as a human, we're giving the direction to the machine, but the machine builds it for us. And this is a trend you're going to see a lot in AI. Humans giving direction, AI doing it for us. The game of Go, very famously, a couple of years ago, Google released an algorithm that beat the champion at the game of Go. The game of Go is very complicated because traditionally computers couldn't solve it because the number of different moves is so huge that you couldn't calculate everything like in chess. So the way the computer did it here is you took one of those neural networks. Each of the pieces of the thing here is, let's say, one neuron of your neural network. You're taking another one, which is playing the other side of the game. And you're making the two play against each other, giving each other feedback after every move. And by giving each other feedback and playing millions of games, they're learning from each other and becoming better and better. If you and I played 1 million games of Go, giving feedback to each other after every move, we would get pretty good. When they designed this 2 years ago, the world champion won 2 times out of 5. The computer won 3 times out of 5. They've just updated the algorithm, actually. They published it this week. Today, the current algorithm they have beats the algorithm that beat the champion 100% of the time. So the current existing algorithms for the game of Go in 2 years became more powerful than any humans or any machine up to that point. It literally became superhuman. And nobody taught it how to play Go. You just gave it the piece. So it's quite interesting because all of that is actually something we call narrow artificial intelligence. What that means is that you're making the machine do one thing. It can do that specific thing better than a human, but it has no idea what it's doing. It's just redoing whatever you told it to do. And this is the exact opposite of what we call general intelligence. So everything you see in movies is something called general intelligence. This ability to have perspective, to sort of have systems thinking ability, to think, I know that I'm actually playing a game of Go, therefore I can maybe reuse that learning to do this other thing. This autonomy in the decision process, its transferability of skills, its general thinking ability is something called general intelligence. Not a single computer today can do general intelligence. My current belief is that I don't even think we're going to get to general intelligence, at least not with the current AI technologies we have. I don't believe that machine learning plus $100 billion in 10 years is going to give us general intelligence like you have in movies. So if you're thinking about using AI in your product and it requires general intelligence, you're not in very good shape. That would be the same as hoping for faster than light space travel for your business. It's just not going to happen, or at least not going to happen with current theories. So this is very important. Keep in mind that 100% of AI today is narrow AI, a machine doing one thing better than a human, but it has no idea, has no consciousness of what it's doing. And it's actually quite good, because it means we can trick machines. So this is an amazing artist's rendering of an autonomous car trap. I love that, because this in one picture shows the difference between general human intelligence and machine narrow intelligence. The car drives better than all of us here, for sure. It doesn't actually have any accidents. It learns that when it sees a dotted line and then a solid line, it can cross. But it crosses this one, and now it's stuck, because you cannot cross a solid line with a dotted line outside. So the car effectively got into a trap and has no way to get out of it. A human looks at this and just thinks, this is absurd. This is like, who did that joke on the floor? The reason is because you can take perspective, right? You're zooming out of your current context, which is driving, and you're thinking, nah, that doesn't make sense. And you're making a judgment based on a second-degree thinking. The car doesn't have second-degree thinking. It's first-degree intelligence. And this is exactly the difference between narrow first-degree intelligence and general second, third, fifth-degree intelligence. As long as we have second-degree thinking and machines have first-degree thinking, we can build traps against artificial intelligences. Right? So that's pretty reassuring. I think we're going to be safe, right? And look, it's deceptively elegant and simple. You can check out, it's a guy called James Bridle, really cool artist, does a lot of cool stuff like that. So anyway, so I'm talking about all of this because we're seeing more and more use cases in everyday life. So this is something called the Amazon Echo. Who's heard about it? Yeah. Over 90% of North California homes have an Amazon Echo. Yeah, they're selling, I've heard, 1 million a month in America. In America, right? 10% of American households have one. That's crazy. This is a level of adoption we haven't seen even with smartphones, right? So what does it mean when you've got a voice device everywhere in your house? Well, it means that you want to start talking to it about everything. The thing is, it can do very well some simple things. You're asking the weather in London, no problem. But as soon as you want to start asking something a little bit more complicated, it completely fails. It turns out human language is extremely complicated to understand because it's very ambiguous. It requires context to understand what's going on. So in this case here, if I'm in Italian near my Airbnb in London, that's very hard actually. It sounds pretty obvious here for everybody, but for a computer, the first thing you got to figure out that Italian is a place type, not a person. It's perfectly correct semantically to be looking for an Italian person in the street near your hotel. But it's not exactly what that's not what you meant, right? But it is semantically correct. Human sentences have multiple interpretations depending on context. This is very important. There is no one meaning to sentences in human language. But it doesn't stop there. Even assuming that you program the machine to say every time someone is asking is going to be about restaurants, then you got to figure out what Airbnb in London is. Airbnb in London isn't a place. It isn't an address. It's actually a reference to something that is different for each of us here. My Airbnb in London is not your Airbnb in London. Depending on who is talking to the assistant, the interpretation of this is going to change. So right now, if you ask this to your Amazon Alexa, it's going to fail, right? Because to actually get this and answer these things, you need to access a lot more data, right? You need to know everything about the person. If you want to build a truly personalized smart assistant, you got to give it data about everything. You need to give it your history of places you've been to. You need to give it access to your text messages, to your emails, to your contact list. You should actually let it record everything you see and hear as well, because there's a lot of verbal and visual things that go into your memory. In other words, you need to give your assistant a complete recording of everything about your life. When you do this, you can figure out the Airbnb's location provider, that you've got emails from Airbnb, that one of them is talking about London, and that the dates correspond to today, so therefore this is the address that you meant. So you see how by recontextualizing what you're saying, you're able to actually give a correct, good answer to the user. So that's pretty scary. I don't know about what you guys think, but the prospect for me of giving so much data to a computer is not something that makes me very comfortable. Nonetheless, we're seeing more and more of these happening everywhere. Voice is becoming a universal interface. We've got it in, music speakers. We've got it in TVs. I mean, TV is a great example, by the way. I was talking to a major broadcast company. They were telling me they've got a voice in the remote. They have 1 billion queries a month. Like 1 billion people, 1 billion times people are asking, play this on TV, play this on TV. So much more effective than trying to figure out, which channel the soccer match is playing, right? Cars, very big use case. I don't know about you, but there's so many features in my car, I have no idea how to use it anymore, right? So it's in the winter, I've got condensation on my windshield. I have no idea what the button is to actually take it off. So what I do, I put my window down, and then I'm cold. Then I wasted energy, making it cold and hot again. But I could just talk to my car. I could just say, hey, take off the condensation on the windshield. Or I could just say, hey, play me the music I was listening to yesterday when I was driving to work. Or you could say it, just drive me to my next meeting. Like, you could imagine a lot more natural interaction, which wouldn't require you figuring out how the car actually works. But again, all of that means that we've got even more issues. So one of them, for me, an important thing when you think about AI, and especially about assistants, is the issue of privacy. Last week, for example, Google demoed something, the Google Home Mini, so a mini version of the Google Home. They gave it to a bunch of people as early tester. Bad luck, one of the journalists who got one actually discovered there was a major flaw. The Google Home Mini was recording everything he was saying. It's supposed to only record when you talk to it. It was recording everything. It turns out that a hardware problem in the device made it believe that you were touching it and activating it all the time. So it just kept on recording what you said, sending everything to Google. Now, let's be clear. Google is arguably the best technology company in the world today. If they make those mistakes, what are you going to imagine of those hundreds of companies building connected devices for your house? Like, the likelihood that one of those devices is going to have a bug that's going to listen to you 24/7 is 100%. The moment you record voice and you send it to the cloud, you're guaranteed that you have no more privacy. That's a fact. So fortunately, we have a lot of good things in Europe happening, One of them is called a GDPR, which basically means that all of those things theoretically wouldn't be private by design and therefore wouldn't be theoretically allowed in Europe. So this is very, very important because this is not something that America actually cares about that much, but I believe that the GDPR is the Y2K bug of privacy and data. People who are building devices and handling personal data who are not paying attention to what's happening in Europe with regulation are going to get massively hit in May 2018 when this becomes active. If you're a company and you're handling any kind of sensitive data, you have to look at this very, very seriously. It turns out we have the technology to do all of this with privacy. When people tell you do things in the cloud, it's not necessarily true. Those things you're talking to, they're computers. Your Amazon Echo, it's a computer. All of those things have, sometimes a processor has RAM, has everything. Why would you send your voice to the cloud if you've got a computer you're talking to who can maybe do it itself? It turns out that technology today is so advanced that a small $10 Raspberry Pi could run the equivalent of a Google Assistant or Amazon Alexa. You don't have to do things in the cloud. This is a false dichotomy that people have been trying to make us believe that you have to choose between AI or privacy. You can actually have both of them together, and we should have both of them together because this is the only way we're actually going to feel safe about using those technology. So why am I talking about all of this? I'm talking about all of this because, I don't know about you, but this is a future people have been telling me about, right? This is a scene from The Fifth Element. Tall metal buildings, everything's gray, very polluted, huge advertisings everywhere, policing all the time. It's a very, very anxious future, right? But it turns out when you talk to people, when you ask them, what's the kind of future you want? What's the kind of future you want? Every single person answers this, right? It turns out people don't want to live in a futuristic sci-fi movie. They want to feel peaceful, They want to feel like when they're on holiday. They want to feel disconnected. And for me, this is really what AI is about. It's about the ability to keep all of the advantages of being hyper-connected in all technology, but create the sensation of being disconnected, of being unplugged. It's really about making all of that technology disappear. Thank you.
Thank you very much, Ryan. Since we have some time left, I would be open to have some Q&A now.
Sure.
And since you opened us some perspectives now on a very interesting topic, gibt es irgendwelche Fragen im Publikum, die wir jetzt stellen wollen? Mikrofon wäre hier.
Auf beiden Seiten.
In English or French, please. I don't have one of those automatic translators yet.
So how do you avoid building biased AI? If AI learns from humans, how they talk, how do you avoid building AI which is also racist or whatever because it copied from human language?
Yeah, I think that's a real issue. I think, I find it very wrong that some people believe the risk of AI is taking over humans and killing us. This is just, sensationalist talk. And, there's a lot of very influent technology people who say that. But when you actually talk to AI researchers, so people who actually build those things, nobody believes that AI is going to kill us someday because nobody believes that we're going to get to that point anyway, right? So bias in artificial intelligence is a real issue. I'll give you an example. When you want to understand language, the first thing you need to do is you need to convert words into numbers because computers don't understand words, understand numbers. And the way you do this is you basically pretty much take Wikipedia, right? And you use Wikipedia to find how words are linked towards each other, and you use this to convert to numbers. So what that means is that you're learning how different concepts are associated in Wikipedia. It turns out that when you look at what is the job that is the closest to the concept of a man, the answer is lawyer. When you ask what is the job which is the closest to a woman, the answer is woman at home. Like, I don't know how to say in English. Like when you stay home and take care of the kids, basically. So in Wikipedia, there is a bias in the way that jobs is represented based on gender. So if you're building an AI system that's supposed to help people choose a career path, and if you've got all of those biases, you're not giving people equal chances. You're making it worse. So this is a very, 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 very big issue. And the reason why there are biases, by the way, is because Wikipedia is mostly white male from America. So, you know, no, for real. Like, that's the most editors from Wikipedia in English are white male from America. So this is a very, very big topic, and there is no easy answer to that. There is no easy answer because bias is also a very subjective feeling about some topics. So what is like a bias, what is not a bias? You know, how do you create an unbiased system? There's many, many people working on that, but you have to accept that there are biases in AI, and whatever bias is in your data that you're using to teach AI will be in the results of what your AI will do. So you know, if you're working on the PR and communications department of a company, you got to prepare also from some backlash eventually. It's just part of the game right now. So this is a very relevant question. I really urge you to consider that as one of the most important topics in AI right now.
Thank you. Second question
No.
here.
Upstairs?
Over there?
Yeah. Then
You touched on, with your answer, you touched on my question a little bit already. If you look at the media right now, and you see a lot of news and discussion that is more geared towards a future where we maybe have something like general AI, and I tend to see like two camps. The one camp basically says once machines suppress the capability of humans, they are going to be the savior. Everything is going to be just fine. And the others draw more like a, let's say, a dystopian kind of picture where maybe Skynet and machines are going to kill us. Or so I would love to hear your point of view and your understanding as a researcher and practitioner on that.
So you mean on the topic of job automation because of AI?
Yeah, just in general. I mean, what if you look like 50, 100 years down the road, let's say we reach that point of general AI.
I mean,
do you more have a dystopian or a futuristic?
So there is a very strong hypothesis that you're making here, which is that we will reach strong AI. I don't believe. I think today, we have no path to strong AI. We have zero idea how we're going to build it, if ever. If I ask you, hey, I want to build like a Star Wars ship that travels faster than the speed of light, great. We can think about the consequences of that. But in practice, physics today don't enable you to do that. The theories don't actually enable that. Same thing with AI. The theories of narrow AI, which is machine learning mostly, doesn't actually lead to general intelligence. And so, we can definitely talk about that, but my short answer is, I don't know, right? And I think that for the next 10, 15 years, which is where most of the societal change is going to happen because of this AI, to some extent, it's not the question we should be asking. The question we should be asking is, what's going to happen to society, to companies, to all of us, when narrow AI will be everywhere? Right? That's already massively disruptive. We're never going to get to general intelligence if we don't figure out how to deal with narrow intelligence. So I know I'm skipping your question because I don't have an answer. But I just think like there's so much pressing issues with narrow AI that we could think about.
Thank you. Next question here.
Thank you. So you showed us the narrow AI on the one hand side and the general intelligence on the other hand side. And once we start to believe that we are moving to the general intelligence, I ask myself, so once we reach this status of, I believe it's called singularity, where we have the same level of intelligence with the human being and the machines, or the computers. So I ask myself, if we as human beings have a more or less linear evolution, and we have exponential evolution in more or less everything that's digital, what makes you believe that we are able to control what we start when we have the same level of intelligence, and the artificial intelligence is evolving exponentially, while we and our brains are only evolving linear?
So, I mean, actually, I'm going to say the same thing. I don't believe we're going to have general intelligence in machines. Not anytime soon. Definitely not in the time frame that Kurzweil is talking about with singularity. What I think is likely to happen, and my interpretation of the singularity, is not that machines and humans will be on equal footing of intelligence. It's rather that machines and humans will merge into a better intelligence. So human horizontal thinking capabilities plus machine vertical powerful execution is strictly better than either of them alone. So I think, you know, the singularity might happen if we figure out a way to combine our thinking and our brain with machine brains. And you don't need general intelligence to do that. You just need better brain implants, and many people are working on that. So that, I think, is a more likely scenario. Human intelligence augmented by narrow AI intelligence. And the combination is explosive.
Any more questions? Over there in the back.
I completely share your thoughts on GDPR and all that stuff, but
you're German, you cannot say but. France and Germany are the two countries that care the most.
Yeah, that's true. And I actually really share your thoughts on that one. But I think as a small company, or if you don't want to give all the data to Facebook, Google, Apple, and so on, you need to collect data to train your models. So right now we are, would you agree that we are right now in the phase where all AI needs to collect data to get models running that later you might say, okay, I don't need data anymore. So
it depends on the use case.
Yeah.
So there are two parts to your question. The first one is whether or not the Europeans will care about European companies or small European companies. I don't think so. I think the Europeans, if I look at what I've seen in politics in France, at least, it looks like they're going to be a lot more laxist with European companies and giving them time to be GDPR compliant, but they're going to hit hard on American and foreign companies. It's a great way to get money back, you know? So I think they're going to prioritize definitely foreign companies when it comes to compliance and comes to audits and things like that. So I wouldn't worry as a European company. I wouldn't worry about compliance in 2018, but I would worry about it in the next 2 years for sure. When it comes to training the AI, that's a very interesting question. So the problem is that even if you had all of the data, there are some use cases for which data doesn't exist. So just collecting data doesn't solve every problem of training AI. And there's a very big trend happening right now around data generation and data augmentation. The idea is that you're creating data to teach the AI out of nothing. So we do that, for example, in our company. We don't have access to any data, and still we have amazing voice technology. And the reason is because we actually simulate tens of thousands of people talking to machines, and we use that to train the models. So we have zero data from real users, and we don't care. We create the data we need to teach the machines. And more people are working on that. So I expect the next big trend in machine learning will come specifically from solving that problem of how do I train a machine without data? Without user data.
Thank you very much. Very last question. Anything in the room?
So in short, you can be GDPR compliant and do AI, no problem.
Or are we good to go? And I would say thank you very much again, Rand.